Okay, so today we're going to talk about proving lines are parallel. Um, these are not necessarily always proofs in the sense that we used proofs in chapter 2. They are a little bit different, similar, but not as painful. So, when we're proving lines are parallel, most of the time we're just going to be using one postulate or one definition to show that yes, in fact, these lines are parallel, or no, we cannot prove that these are parallel. So in these proofs, if you will, proofs in quotations, we are more so, I would treat these more like a true or false, with you justifying, of course, the true or false statement, which we'll get into examples of those in a minute. We're going to go over our new postulates and our converses quickly. So, our first postulate is the converse of corresponding angles postulate. So, if we remember converse from last chapter, what that means is that we're kind of flipping around our initial postulate. So, the corresponding angles postulate says that if you have two parallel angles, then two parallel lines cut by a transversal, then those the angles that share the same relative position, then they are going to be congruent. So our corresponding angles postulate would say, okay, angles 1 and 3 are congruent then. What the converse says is that if two lines are cut by a transversal so that the corresponding angles are congruent, then the lines are parallel. So our new statement says, okay, we don't know that these lines are parallel, but we do know angles 1 and 3 are the same, so therefore we can say, yes, lines A and B are parallel based on the converse of the corresponding angles postulate. So instead of proving that our angles are congruent, now we are using our congruent angles to prove that the lines are, in fact, parallel. So the next one is our parallel postulate, which is if given a line and a point not on the line, then there exists exactly one line through the point that is parallel to the given line. So essentially what this is saying is if you have one point that's not on a line, you can make one parallel line to the initial line that passes through that point. That's about all there is to say on that. So these next four are going to be just like that initial converse of corresponding angles. These are the converses of our alternate exterior, consecutive interior, alternate interior, and perpendicular transversal theorems. So these are just all the converses of what we talked about in both 3.1 and 3.2. So I'm not going to take any time on these. If you'd like to copy these down, you can. Or you could make a note in your notes pretty much saying, okay, the converse of these theorems just say if the angles are congruent or if the angles add up to 180, then the lines are in fact parallel. So once again, all of these are proving that the lines are parallel based upon the angles being congruent. So it's pretty much the backwards way of what we did in 3.2. Yeah. So an example of a problem that you might see would be given that angle 1 and angle 3 are congruent, is it possible to prove that any of the lines shown are parallel? If so, state the postulate or theorem that justifies your answer. So what I see when I see that 1 and 3 are congruent, right off the bat, I see, okay, if I drew in, let's just continue this line just so it looks a little bit more familiar to us. I can see that 1 and 3 are on the same side of the transversal and that they correspond in position between line A and line B. So I feel comfortable saying that line A is parallel to line B. And now my justification for that, if I go back to my postulates and theorems, I know on the first page we had the converse of corresponding angles postulate. So I would say these are congruent, or these are parallel, because 1 and 3 are congruent. And so I can use converse of corresponding angles postulate. So converse corresponding angles postulate. Pardon my spelling, I don't teach language arts, so I don't know if I spelled corresponding right or not, but we're living with it. So, long story short, if we assume that these are parallel, I can say that 1 and 3 are, in fact, congruent based on my given information up here. So, if they're congruent, then A and B must, in fact, be parallel. Since we have no information on angle 4 or line C in general, then there is no way for us to prove that that one is congruent. So we're just going to erase that and pretend it doesn't exist. So we can say that angle A and B, though, are parallel. Second problem you see is given that angle 1 and angle 5 are congruent, so angle 1 and angle 5, is it possible to prove any of the lines shown are parallel? Okay, so if the only information I have is that angle 1 and 5 are congruent, then I can only say that that line L and line N are parallel. And the reason for that, again, is the converse of corresponding angles. So since 1 and 5 share the same relative position on the intersection of line P and line L and line P and line N, then they are corresponding angles. And if they're corresponding angles, then line L and line N have to be, by definition, they have to be parallel. So yeah. Now our next one. These get into the harder problems. So these are once again working back into algebra, algebra. Yeah, sorry. My brain is not working today. Already made 2 videos. Third one getting a little fuzzy. So let's just power through it. So find the measure of angle ZYN. So the measure of angle ZYN, let's go ahead and highlight that theoretically. What is going on? No. ZYN, so that yellow angle. So that line PQ is parallel to MN. Show your work. Okay. So if PQ is parallel to line MN, I can say that my yellow angle must be congruent to angle PXW because they're alternate exterior angles. Since they are alternate exterior angles, what I want to do is I want to set them equal to each other. So I want to set angle PXW equal to angle ZYN. And the ulterior motive for setting them equal to each other is that they're the only angles that we have measures for, so we're kind of stuck with using them. So if I substitute in my values, so PXW is 11x minus whatever that was, minus 25 equals 7x plus 35. So I'm going to solve this by getting all my x's on one side and all my numbers on the other side. So to do that, I'm going to add 25 to both sides. I'm left with 11x equals 7x plus 60. I'm going to subtract 7x to get my x's to the left side, so minus 7x. Left with 4x equals 60, so I divide by 4, x equals 15. So I have x equals 15. I'm not done yet, though, because they want me to find the measure of angle ZYN. They don't want me to find x, they want me to find the measure of angle ZYN. So I have to plug this x equals 15 back into the equation for angle ZYN. So I know angle Z, see if I can actually write ZYN successfully, equals 7x plus 35. So if I sub in 15 for x, I'm left with 7 times 15 plus 35. 7 times 15 is 105. So I have 105 plus 35. So angle ZYN, which is really hard for me to say for some reason, equals 140 degrees. Now, knowing that and knowing that PQ and MN are parallel, I could find all the other angles, but it doesn't ask me to, so I'm not going to. Continuing, so for this, they want us to find x so that GH and RS are parallel. So if these two lines are parallel, then let's see. So once again, I only have two angles here where they give me measures, which is GBA and SAB, and they happen to be alternate interior angles. So once again, I can set them equal to each other. So I can say angle GBA equals angle SAB. I hate when they use S because it looks like a 5, which is maybe a little bit finicky. But anyway, so I'm going to substitute in my equations. So 9x minus 21 equals GBA, so I'm going to substitute that in. And I'm going to substitute in 7x minus 3 for SAB. And then we're going to go about solving it just like we always do. So plus 21 to both sides, plus 21, which leaves me with 9x equals 7x. Plus 18 minus 7x minus 7x, so I'm left with 2x equals 18, and then dividing by 2 on both sides, so x would equal 9. Now we have x equals 9. That's what they wanted us to find, so we can stop here. If they wanted an exact measure, then we would go ahead and plug that back in, and we could find the measure of any of those angles. Now, our last problem is kind of a fun one in my opinion, but it deals with our perpendicular transversal converse. So, in a game of tic-tac-toe, 4 lines intersect to form a square with 4 right angles in the middle. So I'm going to go ahead and label these 4 right angles, because a square, by definition, has 4 right angles. Is it possible to prove any of the lines parallel or perpendicular? Choose the best answer. So, like we've said a couple times recently, if one of the angles is 90 degrees in a set of parallel lines cut by a transversal, then all of them are 90 degrees. So if I look at these 2 parallel lines right here, and let's just say I'm cutting it with this transversal, then I can go ahead and say, then, okay, if this is 90, then this is 90, this is 90, this is 90, this is 90, 90, and 90. And so I can go ahead and say all of these are going to be 90, and all of them are going to be parallel because they're all 90. Because if they're all 90, then they all have to be parallel because they have the same measures between them. So we can say the two horizontal lines are parallel. That's true. The two vertical lines are parallel. That's also true. The vertical lines are perpendicular to the horizontal lines. Okay, so vertical lines up and down, perpendicular. Yep, they intersect at a 90-degree angle. So I'm going to say D. All of them are true. I don't know. I think it's kind of a fun little problem. So for this section, we're kind of doing the same thing that we did in 3-2, just in a little bit of a reverse order. So we're kind of mixing it up. Like I said, big picture in this section is that we are proving that lines are parallel instead of proving that angles are congruent. So we're just doing a 180 on what we did in 3.2, but we kind of follow the same process in